Hello students, today our topic is the resolution in the remote sensing system. So as you know, there are basically four type of resolutions in remote sensing system: the spatial, the spectral, temporal and the radiometric resolution. So if you talk about the spatial resolution, it is the ability of the sensor to detect the smallest object in the target, or simply we can say that it is the about the pixel size. If you see the example, like spatial resolution means the which have more pixel size, it means it has more spatial resolution. Like if you take a photograph, for example, if you have 48 megapixel camera, or if you have another camera which have the 68 megapixel, so the 68 megapixel camera have more spatial resolution than the 48 megapixel. So this means the spatial resolution will be more in high megapixel camera, so which have more pixel size. So this is about the clarity of that image, spatial resolution, the ability of the image to detect the smallest object in that particular target. Then next is the spectral resolution. It is the ability of the sensor to work in multiple spectrum bands. Like here you can see in this example, the ultra spectral band can work in hundreds of bands, or the hyper spectral. If it's the ultra spectral, it can work in the thousand of bands. So the ultra spectral sensor has more spectral resolution than the hyperspectral. So working in different bands, it is the ability of sensor which will increase it spectral resolution. Next is the radiometric resolution. It is the ability of this sensor, or it is about the bit depth, like in how many bit it can work. So see the example, if like there is a 1 bit, uh, it will work, or it will shed the black and white only, like black and white. But if you had 2 bit depth, it will differentiate in the 4 shades of the black and white. In the other picture you can see the 3 bit, it will differentiate the 8 shades. Or if like it is 8 bit, if you increase the bit depth, it will increase the shades. Means it is the ability of the sensor to differentiate between that particular energy or that signature. So this is the ability of the sensor to detect the difference. So if it has more bit depth, it will have more radiometric resolution. Like if it's a green tree or a light green tree, it will differentiate in that if you have more radiometric resolution. Then next is the temporal resolution. Temporal resolution simply is the revisit time of the sensor. Like in this last you can see that the polar satellite is there, so it will take a capture of a particular place. Again it will take that particular place image after a interval of time. I mean, it will come back because it is revolving around the earth from pole to pole. So that revisit time of that particular sensor will decide its temporal resolution. If the revisit time is less, then it have the more temporal resolution. For example, you can see in this particular slide, you can see that the example, like the meteosat have the revisit time of 30 minutes. Here you can see the revisit time of 30 minutes. So it has the more temporal resolution because it will revisit in means less time. So this ability of the sensor is called as the temporal resolution. So like this we can say, if you have a high spectral resolution, high radiometric resolution and high spatial resolution, as well as the less revisit time, it will be your image quality, or you can say that your remote sensing data will have more quality, or your sensor have the more power. So these are the ability of the sensors to collect the data, which is called as the remote sensing. So these are four resolutions what we study in the remote sensing system: spatial, spectral, temporal and radiometric resolution. I hope you understand these concepts. So thank you, thanks for watching.